Okay, in this problem we'll do a hypothesis test for a population proportion, so just take a minute to read the problem. Okay, the null hypothesis in this case is that the proportion of people who do not graduate within 6 years in this state legislator's district is no different from the national average, so that it should be 46%. The alternative hypothesis is that the state legislator is correct. In other words, that P should be bigger than 46%. So we take a sample of 423 students, and we find that 49% of them did not graduate from college in 6 years. Okay, so that's our sample proportion. And the overarching question is 49% close to 46%? If it's close to it, we cannot throw out the null hypothesis. We cannot throw it out. But if 49%, if we find it's very different, it's not consistent with that claim, we will toss this claim out and go with the alternative hypothesis instead. So how do we determine closeness? We use the sampling distribution idea that we studied in lesson 6. Okay, so we know that sample proportions vary, but they vary according to a very predictable pattern. Be a bell-shaped curve centered at the population proportion, which is 46%. And then we can calculate the standard error. And if you calculate the standard error, it's a square root of P naught, the claim value of P, which is 0.46 in this case, minus 1 minus 0.46, divided by your sample size, which is 423. So if you work that out, you get 0.0242. So if you mark a couple of standard errors in each direction, what you should be able to immediately see is that 49% is just a little more than 1 standard deviation above the mean. It's right about here. Okay, to figure out exactly how close 0.49 is to 0.46, we can of course get a z-score. So to get the z-score, you're just going to take 0.49 minus 0.46, so your observed p hat minus p divided by your standard error. And if you work that out, you get 1.21. Okay, and that looks consistent with the picture up here. The 0.49 is about a little more than 1 standard deviation above the mean. Since the legislator wants to prove that the claim was an underestimate, we want to prove a greater than statement. Okay, so what you want to do, since we're doing a greater than statement, you want to shade the area to the right of 0.49. Okay, so now this problem just amounts to finding the area under the normal curve, so using table A or using calculators in StatCrunch to help you find that green shaded area. So if you look at the screenshots in lesson 7, I show you exactly how to get StatCrunch to do this. But what you should find then is that you're going to get a p-value of 0.1128. And you see that right here in the StatCrunch output. So that's that green shaded area. Okay. Notice also that the StatCrunch output gives the z-score of 1.21, and it also gives the standard error that we saw up here, 0.0242. In any case, the important idea here is this p-value, and the p-value is 0.1128, okay, which is 11.28%. So what this is saying, and this is the important idea, that if out of the whole population, if 46% of the students don't graduate in 6 years, that if we were to take a sample of 423 students, there's about an 11% chance that we would get a sample result like we did. In other words, a sample proportion of 49% is not a rare event. Okay, so we do not reject the null hypothesis, H naught. Okay, we just want to finish up by stating our conclusions in context. So you want to just end this problem by saying we cannot prove that the legislators claim is true for students in her state.